Hello and welcome again to another video on a series of videos on chemistry revision. Today we will continue to focus on QA or qualitative analysis flowchart type questions. Now in our previous two videos we have given some basic examples of how to solve such questions, and now in the third video we will be also tackling on QA flowchart questions, but with additional concepts in addition to just testing for cation, anion, or gases. Okay, so let us take a look at this question number 5. Figure 5.1 shows the reaction between of metal Y and a solution of metal X. So right at the very beginning here, we have a solution of metal X, which means of course this metal X is this salt is a soluble salt. Okay, now let's take a look at this first reaction here when we add sodium hydroxide with aluminium filings. Now adding sodium hydroxide and aluminium filings is definitely a test for the nitrate ion. Okay, and how do you know if the nitrate ion is present? We will get ammonia. Okay, and here we can see that ammonia gas is given off because we have a gas T that turns red litmus paper blue. So this gas T is definitely ammonia gas, and the presence of ammonia gas here when we add sodium hydroxide and aluminium filings does indicate that the nitrate ion is present. Therefore, this contains the solution X contains nitrate, because as we know all nitrates are soluble. Okay, so let's see whether we can figure out the metal X. We take a solution of X here, and in these two branches we add sodium hydroxide. Now when we know that when we add sodium hydroxide, we are basically testing for cation. Okay, testing for cation usually involves either adding sodium hydroxide or aqueous ammonia. So when we add sodium hydroxide, we get a white precipitate Q that dissolves in excess sodium hydroxide. Okay, so this white precipitate dissolving in excess aqueous sodium hydroxide indicates the presence of either zinc 2 plus ions. It may also be lead Pb2 plus ions, and it may also indicate the presence of aluminium 3 plus ions. Okay, because all these three ions will give a white precipitate that dissolves in excess aqueous sodium hydroxide. So that doesn't really help us a lot, but let's see whether this branch can clarify a little bit more. We add hydrochloric acid. Now we know that this is a salt of a metal X, and we know that it is a nitrate. So let's see possibility if what happens if it was zinc nitrate or lead nitrate or aluminium nitrate. Okay, now if we have zinc nitrate and we add it to HCl, what will we get? Let's switch the ions. We will get zinc chloride. Okay, if we get zinc chloride, but we know that zinc chloride is a soluble salt, so definitely it cannot be zinc. Let's see if it was lead 2 nitrate. Okay, let's see if it was Pb2 plus present in the solution of metal X. We have lead 2 nitrate and we get hydrochloric acid. We add hydrochloric acid. What happens when we switch the ions? We get lead chloride, and we know lead chloride is an insoluble salt because all chlorides are soluble except lead and silver chloride. Okay, so we can more or less confirm that the solution of metal X is a solution of lead 2 nitrate. Okay, so let's confirm that we have a solution of metal X. Let's assume that it is lead 2 nitrate. We add sodium hydroxide, we get a white precipitate that dissolves in excess aqueous ammonia, which is consistent with Pb2 plus. And if we add Pb2 plus into a solution with hydrochloric acid, we get a precipitate of lead 2 chloride. So this is PbCl2 or lead chloride. Now what about aluminium? Could it be still aluminium? Let's see. If this was aluminium nitrate and we added hydrochloric acid, switching the ions, we get aluminium chloride. But aluminium chloride is still a soluble salt. Therefore, will not give us a white precipitate R. Therefore, we can more or less confirm that it is not aluminium and Pb2 plus or lead 2 plus ions is present. Therefore, we can confirm that this is a solution of lead 2 nitrate. Okay, PbNO3 2. Okay, so we have actually already identified the solution of metal X, which is basically lead 2 nitrate. Okay, so now let's take a look at this right hand side of the flowchart. We are adding lead 2 nitrate to a metal Y. Now, what could this reaction be? We are adding lead 2 nitrate, a solution of a metal, with a metal Y. What could this reaction be? Now, if you recall, we're adding a metal to a solution. So this is really a displacement reaction. Metal displacement reaction. Can you remember the law on metal displacement? It says a more reactive metal can displace a less reactive metal from a solution of the less reactive metal. Now, was there a reaction? Did a displacement reaction take place? Well, we started off with metal X, solution of metal X and a metal Y, and we got a solution P. So indeed, there was a reaction. So indeed, displacement did occur. So if displacement did occur, we would now have Y nitrate, and since the more reactive metal can displace the less reactive metal, we will also get solid lead. Okay, now we get this solution P, so we are focusing on this Y nitrate. So this P will be Y nitrate. Now when we add aqueous ammonia to this solution of Y nitrate, and you would remember that adding aqueous ammonia again is a test for cation. Alright, and what do we get? We get a white precipitate that dissolves in excess aqueous ammonia. And you would remember that there is only one cation that will produce a white precipitate in aqueous ammonia, which dissolves in excess. And therefore, that precipitate is really zinc 2 plus. Therefore, this precipitate is zinc hydroxide. Now, let's see whether we're correct. If indeed S is zinc hydroxide, it contains the Zn2 plus. Where did the zinc come from? It came from solution P. Okay, so where did the solution P, does the zinc in solution P come from? It came from metal Y. So metal Y must be zinc. So let's check if this Y is really zinc, can it displace lead from lead 2 nitrate? Is zinc more reactive than lead? Let us recall our reactivity series. Okay, let's practice along with me. Please stop calling me a zebra. I like happy cobras. So go. And we can indeed see that zinc is more reactive than lead, and therefore zinc can displace lead from lead nitrate. Therefore, this reaction will take place and will produce a displacement reaction. So essentially, we have identified all our unknowns. Okay, so let's go. name P. Where is P? P is this solution. Okay, now we know that P is a nitrate. Okay, and since the metal is zinc, P will be zinc nitrate. So P here is actually zinc nitrate. So let's write that down. P is zinc nitrate with a formula of ZnNO3 2. Okay, that's P. Let's see, what is Q? Q here is a white precipitate. Now we got Q, the white precipitate, by adding sodium hydroxide to Pb2 ions, Pb2 plus ions. Therefore, this precipitate must be the hydroxide. So Q is lead 2 hydroxide. So let's write this down. Lead 2, remember to write the 2 there, hydroxide. Formula Pb bracket OH2. Let's see what is R. R is a white precipitate that we got by adding Pb2 plus with hydrochloric acid. So we have determined that R here is lead 2 chloride, the precipitate. Okay, so R will be lead 2 chloride, formula PbCl2. Okay, how about S? Where is S? S here is a white precipitate that dissolves in excess aqueous ammonia, and we know that there is only one cation responsible for that, Zn2 plus, and the precipitate is zinc hydroxide. So S is zinc hydroxide. Formula ZnOH2. Okay, so where is T? T is all the way up here. T was the gas that turned red litmus paper blue, and we know in your syllabus there's only one. So T is ammonia gas. Now it's not really necessary to put a gas there because we know ammonia is a gas, and the formula will be NH3. And we arrive at the last one, X. X is the solution of the metal. Okay, therefore solution of metal X. So the solution of metal X, the solution is lead 2 nitrate. So X here is a metal, so we know X is lead. Simply Pb. Now, okay, it is not lead 2 nitrate because we are talking about the solution of metal X. So X is really just the metal, so we only write lead. Okay, so let's see now we answer this question. Question A. From the above reaction, which metal X or Y is more reactive? Explain your answer. Now we have determined that since there was displacement reaction taking place, metal Y is more reactive than metal X. That's why the metal Y was able to displace metal X from the solution of metal X. Okay, and that confirms because zinc is indeed more reactive than lead here. Okay, so metal Y, which is more reactive, we can see that metal Y is more reactive than X. Okay, that answers the first part, but we are also asked to explain. So according to the law of metal displacement, Y is more reactive than X, so that Y is able to displace X from a solution of X, and that's what happens here. Zinc was able to displace lead from a solution of lead nitrate. Okay, so we can say metal Y was able to displace X from an aqueous solution of a salt containing X. Okay, Y was able to displace X from an aqueous solution of a salt containing X, because after all Y is more reactive than X. Okay, now this question, as you can see from this question, we not only have to deal with test for cation and anion and test for gases. This particular question also weaves in the concept of metal displacement in a QA flowchart type question. Okay, so I hope that this video has been useful for you. You can always pause and rewind sections of the video which you need a little bit more time to digest. So hope that this video has been useful for you. So look out for our next video. See you. Bye bye.